This is a tutorial on how to use random forest regression in ArcGIS Pro. This is a continuation of a process we started in class for GPH 904. So as you may recall, we were looking at this particular article ranking the importance of demographic, socioeconomic, and underlying health factors on U.S. COVID-19 deaths, a geographical random forest approach. So in this article, the objective was to to compare several different methods for predicting factors or identifying factors that predict COVID deaths across the U.S. at the county level. And so the authors were highlighting a new approach, which is geographic random forest analysis. But it's fundamentally based on this very well-known machine learning algorithm called random forest, which is what we're going to focus on. But they also compared it to ordinary least squares, which is your typical regression approach, as well as geographically weighted regression, to show the superior performance of this random forest approach. So what we're going to do here is we're going to replicate their analysis and compare that random forest approach to a couple other approaches as well. So we won't do the geographic random forest since we don't have that algorithm built into Arc. You'd have to do that in R, and that's a different class. I invite you for next semester. So, okay, so this is what we're trying to do, and the authors in their article identified the variables that they used, as well as the processes to do it. So they identified 29 variables, all of which they used to explain COVID death rates. So we started to collect the data in class, but I figured it would be a lot faster to just simply give you the data, and then we can just focus on the process for using the tool as well as interpreting the tool. So in the assignment that's posted in Canvas, you'll have a link to download the geodatabase that has the relevant data that you'll need. So just as a reminder, what we're doing and we talked about in class was this random forest regression and classification system, which relies on a unique process for randomizing the data in order to arrive at a preferred solution to which predictors or which variables do the best job of predicting or explaining a given dependent variable, something that you're trying to explain. So as we talked about last time, the process essentially is that you have a data set, right, and you have some variable that you're trying to explain. In our case, is COVID death rates, and then we have all these other variables that we think are relevant to explaining it, including access to health insurance and wealth of the households and different health statistics like asthma prevalence, things like that. And so what the algorithm will do is it will pull out a subset of that data in this bagging process that we see here in the illustration, and it'll repeatedly pull out a small subset of samples, both in terms of the variables, but also in terms of the records. So if we have, for example, 3,100 records, which is however many counties there are in the U.S., it will pull out a subset of those. But in addition, we have like 28, 29 variables, and it will only pull out a subset of the variables. So it will end up using just a portion of the data at a time, and from that it will build a decision tree. Essentially, it will try to predict the variable of interest, in this case like COVID death rates, but using only a subset of the data, so it doesn't use all the data. And it'll keep doing that over and over and over again, and you'll end up with a whole bunch of different decision trees, each of which tries to predict COVID death rates, but using only a little bit of the data at a time. And what that will hopefully show is that most of the trees that get generated, which are part of the forest, will arrive at roughly the same solution, and each one gets a vote on what is the best set of predictors to predict COVID death rate, and that's how you arrive at that sum on the end that tells you this is the likely answer. And the philosophy behind it is that the use of these randomly chosen subsamples, as well as the generation of these individual little trees that only get a little bit of the data to predict, that those two processes combined are very powerful in identifying the most important factors in prediction. And so that's kind of the underlying philosophy behind how the whole thing works. So as far as a workflow goes, what does this look like? So the way it works, and this is unique, or not unique, but this is specific to ARC, but it's also common, so it's not an unusual approach. So we have to prepare the data, which is, as we probably have picked up by now, is really the bulk of the work. And I'm sparing you all that by giving you the data that you'll need. And if you're curious about it, we can talk about how I generated that, but it is a little bit of a pain and a little expensive too. Once we have the data prepared and ready to go, then we can train the model. So we're basically going to submit a portion of the data to the computer to run through and kind of try to figure out what is the best combination of variables that predict the thing that we're after, in this case, COVID death rates. We will get feedback from the computer telling us how the models perform, how the model performs, and then we evaluate it. And if it's working well, then we're ready to go. But usually what we do is we'll try altering some of the parameters of how the model runs to see if that improves its performance. And there's a lot of choices that could be made here. There's some kind of common ones that we'll focus on, but that's basically what you're doing. And then you do that a few times, and then hopefully that'll reveal, which parameters affect the performance or improve it or don't improve it, and then you can decide which one you want to go with. And you do this until you're satisfied. And there's no clear, benchmark for that. It's kind of up to you. And then once you arrive at that, then that's what you go with, and then that's what you decide is the model for predicting performance, as well as the output will tell you, essentially which variables are important, which is ultimately what we're after in this process. So that's what we're going to do. So in the next section, we're going to walk through and how to do it in ArcGIS from the very beginning with the data that I've given you.